Hello all, I'm Chris Cariciadis, and this is Aqua Agitators, where the real water experts take the stand to share their insights with you, the audience. Today, I would like to introduce an initiative that I would like to call Brine Trust, where experts from all kinds of fields that have a passion for brine and brine valorization bring their heads together on one table and share their thoughts for the future of this part of the water industry. And today, I would like to introduce you to some of them. We have together with us Nicholas Nelson, who might be the first one that can run the quick intro.
Sure. Thanks, Christos. Yeah, Nicholas Nelson, Director of Innovation and Marketing for Omni International, which is one of the world's largest producers of calcium carbonate and magnesium hydroxide. So yeah, we are obviously very interested as brines as a sustainable source for our mineral markets in the future.
Thank you. Paolo, you want to be next? We can't hear you.
Thank you, Christos. Can you hear me now?
Yes.
Yeah, my name is Paulo Matiusa. I'm a co-founder of Brine Act, a company based in Paris. We came from a long history on designing crystallizers for the chemical world, and we rethought the crystallizer for closing the loop on the industrial plants with a special design for taking care of brines, heavy brines, and take value out of the brines.
Okay. Paolo, thank you very much. David, the the mic is still muted.
Sorry, the usual error. As thank you to Christos for inviting me, and I'm happy to be here. My name is Ravid Levy. I'm from Israel, and I'm working at and heading the Israeli water innovation community. I've been working before for companies that were doing desalination and different kinds and different applications. So obviously, brine is a very interesting thing. Israel is depending on desalination for its drinking water, so brine is definitely a big deal over here. So we are very much interested in advancing this aspect.
Great. Eric, you want to be the last but not the least, I hope?
Sure. Thanks, Christos, for having me. My name is Eric Desormo. I'm currently the Director of New Applications for Energy Recovery, located in the U.S. Near San Francisco. I have a background mostly in water, wastewater treatment. I've worked on valorizing brines from quite a few different industrial wastewater ZLD type projects, from wastewater or from valorizing fertilizer to metals to different types of salts. And I'm really excited for this sort of group to exist. So thank you for having me.
And thank you all for taking the time out of your agendas to be here today. Takes takes a lot of effort to gather you all, but I think it's definitely worth it because you are some of the most foremost thinkers of in this space, and it's definitely interesting to hear your thoughts on the upcoming topics. So let's start with the basics here. What do we consider as brines in the industrial wastewater treatment space? Would anybody like to take this up? Eric, for example?
Sure. I mean, my first thought is anything that comes from a reverse osmosis, concentrate line. I would consider a brine or anything that's saltier than seawater. Sometimes we see, especially in the oil field, brines that don't come from reverse osmosis, but may have valuable minerals. I'm sure there's some other non-RO type brines out there I can't think of, but at the moment. But that's my first thought.
You have in general high salinity wastewaters. That doesn't have to be. it doesn't have to be even seawater level. It can be like brackish and still be considered as brine, as long as you can, as it has high salt concentrations. You can still categorize it as far as I'm concerned, and can come, for example, from the mining industry, yeah, oil and gas, pharma, you name it. Any type of wastewater that has salt in there, we can consider it as brine. Um, and here comes my next question on the topic, and maybe a little bit controversial, but does the discharge of brines, the proper discharge of brines, into the environment, do you think it causes any environmental harm? Let's take, for example, the discharge of seawater RO back into the sea. That my favorite topic. So, do you think it makes any difference? Does anybody have any opinion on that?
Yeah. If I can intervene, I think first we start with water from the rivers, okay, and from toxicity. If you consider the level of toxicity of the level of salts in the water, there are a lot of studies around that demonstrate that around 1.7% of TDS as sulfates and nitrate, above 1.6, 1.7, is becoming toxic for the human being. Okay, so if you have a river that is 1.7 is not huge. 1.7% of TDS is just a, a salty brine, like a soup. So when you start from that level, if you drink that every day, you will get intoxicated in very little time. So if you keep on putting salts in the rivers and the rivers become more, you have an impact on the health of the people, because with sulfates, with nitrate, with brines are coming also other things like metal, potassium, PFAS, any kind of things. So it impacts the ecosystem, and the ecosystem is impacted. The fish are struggling. The algae and the all the plants they are living. You change actually the ecosystem in the river, and the same thing happen in the sea at a different level, because the sea has much higher level of TDS. But if you concentrate the sea brines up to a row and you get it back to the sea up to 6-10% TDS, after years you find your area complete heavily salty. I don't know, you have never been, I think, in Bahrain in these hotels close to the seaside, and you try to have a swim on the beach. You almost float there. So uh, fish ecosystem is compromised, and after years these have for sure an impact on ourselves and the our bodies, our life expectation. Okay.
Okay. First of all, I would like
Apology for joining late. I have been trying to join. I had some problems, so
so
sorry.
to all and to the viewers, I would like to introduce Basil Abusark. Thank you, Basil. Thank you very much for joining us. Would you like to run a quick intro before we continue the conversation?
Yes. Hi, my name is Basil Abushar. It's nice to meet you all. I'm the CTO of Osmosis Tech. I'm also the founder of Hyric, the company that built a brine mining project in Indonesia, 200,000 tons of salt using osmotically assisted reverse osmosis. And now I started another company. It's called Osmosis Technologies, and it does the same thing, high efficiency reverse osmosis, and also brine mining using brine concentration, membrane brine concentration. Currently, I'm also an advisor to the Saudi government and to SWCC of Saudi Arabia on projects related to brine concentration, brine minimization, and also in water production, water reduction of the cost and energy consumption of water. We do projects for the oil industry, dealing with produced water with very high salinity, high oil content, difficult waters in general in our company. So it's really nice to meet you all.
Thank you again for finding time to join us today. And perhaps you got in at the right moment when we were talking about the concentration of brines and discharging them to the environment. Paolo was just explaining to us about one, his opinion, it is dangerous to release these wastewaters back to the environment and the increased concentrations that these can bring over time. Paolo, at least as far as I can understand your point of view for the small local ecosystems inland, as such as rivers or lakes or aquifers. But I think I'll have to disagree on the release back to the sea with deep sea diffusion of the brine. I don't think there is a definitive study that shows the negative results of the release of brine into the deep sea. I think there was a study done for a big organization for the release of brine into the Red Sea with hundreds of thousands of cubic meters per day as a theoretical model. And they came out with the idea that nothing would happen to the Red Sea, which is more or less a closed water body in comparison to other oceans. So why do you think that there would be a problem?
Because my example was not related to the deep sea application. My comment were related to the cost side, where the most part, if you manage to have pipes that go deep in the sea, from the rivers, from the borders of the sea, why not? Okay, why not? There is huge quantity of water. Is very hard to increase the average concentration even with these quantities. But when you get stuck to the borders, then the salt is increasing in specific areas, is not getting diluted so quickly. And then also there are all the pollutants. We are not talking of if we are talking of recovery sea salt, I fully agree with you. If we are talking of waste from chemical plants that include nutrients, include metals, include other things that are made toxic, with the time, it can create a problem.
Yeah, that goes without saying.
But-
Toxic.
But I think this underlines also the need for the environmental impact studies, right? With desalination outfalls, and most desalination plants require the environmental impact study to go into place, right? Which generates the need for the the deeper outfalls that you're basically alluding to, right? So the fact that we keep requiring these on the desalination plants is a good thing for us.
Thank you.
I would like to maybe refer to both of your questions, and I think the basic answer to both. The first one was, what is brine? The second one is it harmful to the environment? And the answer to both, it depends, because also I think that the only way to define brine is whatever is more salty than where you put it into. Because if you take a brackish water desalination plant, and then discharge that to the ocean, I'm not sure it will be regarded brine because it's actually diluting the ocean, right? But if you're taking a high salinity or even the same brackish water, put it into the river Pablo was referring to, it will definitely be a brine, and that would definitely make some difference, or could make some difference in there and inland or in other places, or whatever the discharge is. So brine is saltier than the environment where it's being put in, and that also defines, in a way, the potential for environmental damage, and it's about quantity, the specific location, and the receiving body, and the, I know, the Mediterranean, the Red Sea, and the Pacific Ocean are not the same, and in closed bays, in any of them, it's different than in the open or deep sea. So Nick was right. It's a very case-specific thing, and we cannot generalize that it will never do any harm. Obviously, it cannot also be generalized that it's always a damaged thing and it should be avoided. It's a very case-specific. And one more thing, it's an alternative issue, because if you're considering a seawater desalination plant as a strategic water supply to a country or to a city, if there is a better alternative to supply water without discharging the brine and without using the energy and without doing all that, most countries will choose those cases. But when the other options are exhausted, you have to choose the least damaging one, and then do the studies and make all the efforts to minimize the damage, the cost, and anything else.
And this is
Right.
exactly so. Sorry, Basil, please.
I agree, and I think if we talk about two cases here, a place where we have the largest seawater desalination capacities, that is the Arabian Gulf. We have the largest capacity of desalination between Saudi Arabia, United Arab Emirates, Qatar, Kuwait, and that Gulf is very shallow. And the rivers that used to flow into that Gulf are now diverted, and very little rain. And the Gulf the salinity is increasing, and the ecosystem is changing. I mean, a few years, it's 10 years ago, the salinity in some places was around 40,000 ppm. Now we see salinities of 55,000 ppm. We're talking about a Gulf in which you go for like a few meters.
Basil,
So that's a problem. I think in the Arabian Gulf, that it is definitely causing damage. Talk about another practical example, which is brackish water desalination, inland desalination. What we see is that in a lot of the dry countries in which they rely on underground water, whether deep aquifers or medium depth aquifers, is that the salinity keeps increasing because people have no place to discharge this brine. So discharge it maybe little far away from the desalination plant, but it finds its way. The salt finds its way back to the aquifer, and salinity keeps increasing year after year. So it definitely has an impact, especially in dry regions where desalination is needed. But in other places, I agree. I don't think it will have. If you would desalinate near an ocean, you do a mass balance, and you see that it takes forever to change the salinity of that ocean.
As far as I know, in open oceans, in Australia for sure, even along the Mediterranean, the studies so far have not shown any significant long-term damage, maybe beyond the immediate location of the discharge, but going even slightly further away from there, as far as I know, all studies so far shown that there is no lasting damage. The Arabian Gulf is possibly an exception to that rule, and because of what Basil said, the balance between its being relatively closed and shallow and the huge capacity of desalination all around it. it may be different. Yeah.
As far as I'm concerned, the thing is that I was never really interested so much for the direct effects of brine in the environment, but rather seeing it as a potential opportunity, as a lost opportunity, if you discharge it, yeah, for the recovery of water and the recovery of minerals therein. And this is what we
Christos, that's because you're an engineer.
too much common sense in
Yes.
the in the
No, I'm
sector.
joking, of course.
And this is what we would like to call brine valorization, right? So the thing is, no, but as of late, we used to imagine brine valorization, what I would like to call full brine valorization up to now. But nobody ever gave a thought to that maybe partial brine valorization is still a thing. Like even for me, for example, even recovering water out of a brine is still valorization. I don't know if you gentlemen share the same.
Crystal, I think this is worth maybe, first of all, maybe a broader perspective before we dive into the details. I think that basically the, the meaning of brine valorization is that water will stop being the only product of desalination. And this is a paradigm shift before it's a technological shift, because everybody builds desalination plants to produce water, and all the rest is called reject, waste, effluent, whatever you want to call it. We call it brine because we like that term, but it's basically something to get rid of with the least cost and the minimum damage to the environment. And water is the only product. Now, unfortunately, water is a very low cost product. Not unfortunately, actually fortunately, because otherwise we would all go dry, and water has a lot of value for the public and for everyone, so it must be low cost. But in terms of the manufacturing of water, and desalination is a factory manufacturing water, it basically means that we need to invest a lot in order to produce a high quantity, low value, or low cost, high value but low cost product, a single product. I mean, imagine a desalination plant being built next to a refinery, right? Both may cost the same to build. Let's say, I don't know, $500 million of a big capacity. One is producing huge amount of single product, liquid product at the $1 per cubic meter, more or less, right? These days, maybe $2 desalination. The other one produces liquid products, few products, many products, at about $100 a barrel, which is about 3,000 times more. Now, the balance here is a problem. Now, valorization of anything out of what we call waste will eventually create another income to that plant, which may be, in theory, higher than the original product. And then water will become a valuable byproduct, but not the only basis for the operation of the whole thing. And now we can start looking at what is worth recovering out of there. Is it everything or partial or even water itself? But I think this is the basis for this whole discussion. And by the way, that's the whole basis of any recovery of any waste, from wastewater, from anything, including brine.
Thank you, Basil. Thank you, Ravid. Basil, you wanted to talk?
Yes. Yes. Okay. I think when we talk about brine valorization, then we have to ask first why we're doing it. Is it we're doing it for the economics, or we're doing it for environmental reasons? Now, environmental reasons, people would pay any amount of money. That's should, I mean, that's not really okay. If you need to get rid of the brine, you have to get rid of the brine. So regardless of how much it costs, people will have to get rid of it, and it becomes a matter of optimization. What technology will produce the lowest capex and opex. Now, when it comes to economics, and we're talking here about seawater brine. I think this is what we're talking about, because there are so many brines around the world that are already economical to produce potassium or produce lithium. But we'll talk about seawater desalination brine. And in that case, the economics are very tricky. It works under special situations, you know. I say this because I've been in this business for the past 5 or 6 years. I think probably I'm one of the oldest people in the world that started worrying and thinking about this and commercialize the technology and build commercial plants. So it works under special conditions. Now, if you valorize the brine, then you produce salt. That is probably 90% of what you produce some potassium, some magnesium. These are the valuable stuff. Lithium is almost out of the question. You can never compete with commercial brine, even with low concentration brine. You're talking about 0.1 ppm in the seawater, or in the brine, 0.2 ppm. So there are specific situations in which the economics will work. An example of that is the Indonesia plant. Indonesia is a country that has a huge demand for salt, and the salt price is high. It's a rainy country, so solar evaporation of seawater, it doesn't make a lot of sense. So it works. The economics worked in that specific situation. It works in certain countries, like maybe in Japan, in which they have a policy for national security of salt. They have to produce a local production of salt. They have to produce a certain amount per year. So Japan can be a good place, maybe Korea. But if you talk about other countries, then the economics are very challenging, very, very challenging. The salt is not valuable enough to justify the additional cost of evaporation. And there's also one important point, which is, I think to make this thing work, brine valorization, we have to use solar energy somehow, solar and wind energy. So there has to be a component in any project that I studied. Introducing a component of solar or wind evaporation just makes the economics work. You know, desalination, brine, then concentration using membrane brine concentrators, which consume little energy, can achieve very close to saturation. And then that crystallizer step is usually very expensive, energy intensive. If you can replace it with solar evaporation, then the entire thing can make economic sense. And of course, there's an advantage here, because you already, by squeezing the brine, you already reduce the volume of that brine substantially by membrane brine concentrators, and you will need much smaller area to evaporate it. And using enhanced evaporation will further reduce the area required for evaporation. So it can be made economical. There are specific conditions, but it's not just, you cannot say that it is always makes sense. I think in most cases, 90% of the cases, it makes no sense.
Thank you, Basil. Nick?
Yeah, I just wanted to reinforce, I think, what Basil was saying. Like, I think we talk about brines, right? And we know that brine mining works, you know, in particular scenarios, right? We see that lithium-rich brines has already been a great source of extracting lithium. A lot of companies who produce magnesium hydroxide or magnesium compounds are working from magnesium-rich brines to start off with, yeah? But we all come from a, you know, desalination background, right? We've all touched on desalination a little bit. So we're thinking a little bit along the lines of, can we make brine mining work on desalination brines? And I'm yet to see a really strong business case that sort of is able to demonstrate, you know, that we're able to do that quite effectively. And I think the other point is that maybe to get to some of the more high value products, we need to extract out a lot of the low value products. And suddenly, all of a sudden, the amount of low value products that are coming onto the market, even if we just need to take the sodium chloride out to get to the other things, the amount of sodium chloride that could come onto the market could, you know, well imbalance our needs for the other metals and minerals that we're trying to extract. Yeah, so it's more a case of focusing on maybe types of brines with the right concentrations and, you know, for market needs, rather than just going, is desalination the right outlet for us?
Understood. Sorry. Does anybody have any other Ravid?
I wanted to refer to Christos' remark about partial, because I think one of them, possibly the hurdle towards valorization of brine, and that may be the next question, is when it combines immediately with ZLD. So let's get rid of brine and then valorize everything which is there. And everything which is there, at least in most brines, of course, Nick is right. When it's a specific rich brine with something, it's a no-brainer. Everybody, it's done already in a way. But when it's just the normal brine, let's say seawater brine, I don't know if it's 90% or whatever. Nick Christos knows the numbers of sodium chloride, and sodium chloride, except for those rare cases, is a no value, not a low value. It has no value to produce, because it's produced in masses for free almost in most dry places. So we need to ask, what are those things that we can still get value out of those brines, which will not eliminate brine. It will just pick out those things that have specific values. And the examples I know that are already there, it's maybe like the tip of the iceberg, of course, is, for example, producing chemicals for the use of the plant itself, like hydrochloric acid and caustic and those things. And in those cases, there are sometimes strong business cases, because otherwise it needs to be bought, because it's made elsewhere and delivered, and all the hazards and everything that is considered with doing that, or producing chlorine locally, right? Electrolyzers out of the brine to save liquid or gas chlorine for disinfection. Of course, it will not remove all the chlorides from the brine, but it still gets some value out of that. The next step is carbon dioxide for the post-treatment, rather than buying it gas, extracting it from either the brine itself or from, which is a different issue altogether, from flue gases from the power plants or gas motors that are used on the plant itself. And last, and that's maybe the new horizon here, is hydrogen. And that's again some companies and some technologies are being developed to use brine as an electrolysis or other processes to recover hydrogen out of the brine itself. And again, the brine will keep flowing into the ocean, and the question of is it harmful or not will remain, regardless of the fact that there's a new product made out of that.
Yeah, and I would like just to add on to that. When you ask about partial valorization, when you look at some of the reports that have been put out in the past from NEOM or others, they talk about magnesium specifically, and Nicholas, I would really like to hear your thoughts on this. But a lot of the projections, when you look at industry, the future of which kind of minerals and metals will be needed in the future, magnesium metal seems to be something where the demand will be growing quite a bit in the future. And if that's true, it looks like seawater will be one of the primary sources for that. So I'm very curious to see, as the industry advances and as technologies advance, especially in locations where the energy cost is very low, because I know electricity would be a big part of making magnesium metal usually. I'm curious, Nicholas, what you think of magnesium, particularly being a target for partial seawater brine valorization.
To be honest, I think magnesium may be the only one that I'd look at from seawater. Yeah. There was a really great presentation that was given by Professor Chris Fellows at a joint conference that Christos and I were at, who talked about value, like the free Gibbs energy of the various metals and minerals in seawater versus their value on the market, right? And you had to look at those in relation to each other, and magnesium was really the only one that sort of stood out in terms of going, the amount of energy that needs to be put in to extract that based on its concentration versus the value on the market is something that we can work with. And we know that there is already some companies around the world who have been able to get a suitable business case based on that. Yeah. Obviously, though, if you're competing from that perspective against another company who's got access to a highly rich magnesium brine, right? I mean, if we took it, Dead Sea or something like ICL, or we know there's some very high magnesium-rich brines in the middle of the US, then your business case might be a little bit more flimsy, and more relating on cost of energy and so forth than the other one. So, do you have a strong presence there in terms of being able to maintain that going forward? I'm not sure. Having said that, one more point, before I think Basil's got his hand up as well, is that the EU's been very forthcoming, sort of putting together a list of critical raw materials, right? Magnesium's on that. We rely a lot on the import of, magnesium minerals coming from the calcination of magnesite from Chinese sources. And I think they've identified the need to have our own sources as well, because of the growing need for magnesium as metals, also going into the manufacture of a lot of the auto industry and electronics industry.
Basil, your microphone is mute.
Okay, sorry. Yeah, my comment is about again magnesium. Now keep in mind that Dow used to produce magnesium from the sea. That was up to 20 years ago. And they used to do that economically, and then they were phased out of the market when the Chinese came up with their extraction technologies from magnesite or dolomite, the solid sources. So they became the dominant producer of magnesium, and the economics of that process are much better than the seawater or the concentrated magnesium brine. So as Nicolas said, it makes sense to produce it from destination brines if there is a security reason. For example, a country wants to produce it, or a continent in this case needs to produce it because of security of supply, especially that magnesium is an important component in cars. I think it makes cars lighter, especially when you talk about electric cars. So yes. So again, even with magnesium, which is the second, I think, highest cation concentration in seawater brines, you can also further concentrate it using nanofiltration, up to seawater 1,200. I think brine 2,400 with the nanofiltration. I think you can bring it up to 4,000 ppm, which makes the economics even better. So but the general rule is that it's really difficult to make the economics work if you don't use solar evaporation. If you have the land to solar evaporate the concentrate, then the picture changes, and then it can make sense. But of course, again, everything is location dependent. If you are next to a chloroalkali plant or to a soda ash plant, then your salt will have value. But again, how much salt? The global salt market is around 350 million tons per year. And if you look at even if you want to valorize the price of desalination plants in Saudi Arabia, then you produce more than that, just from the desalination plants of Saudi Arabia. So you have also a market constraint on what you can produce and how to channel it out. And yeah.
So, riding on Basil's last comments, do you think that what are the main hurdles for the implementation of brine treatment and brine valorization today? What do you think that we need to improve or change in our approach in order to see more brine-related projects in the market? Basil?
The cost?
David? Sorry.
I just think the cost. Once the cost is there, it will happen, of course. It will take a lot to reduce the cost because of everything we said so far. Or in fact, of course, the balance between the cost and the value in the market, but it always needs to come together. We're still not there on most things, I think.
Sorry, Basil, before I give you the stage, the thing is, though, that we are at a point in the water treatment history where we have managed with membrane concentration to reach all the way up to 250 grams per liter. This is the cheapest that we have made to concentrate this high. So if not now, when? Basil? Yeah, you're
Unmuted? Unmuted, yes. Yeah, valorization of seawater desalination brine remains a case-by-case situation. Very difficult to generalize. Very difficult to generalize. Now, there are, as I said, definitely there are cases in which makes economic sense. I think the introduction of membrane brine concentration made that more feasible because it bridges the gap between seawater RO, ultra high pressure RO, and thermal evaporated crystallizers. So that is there is a gain in capex and opex, but still, even with that, it is economical on a case by case basis. Again, it all depends. Is there a demand for the salt because that's the largest product? Is there a demand for a specific salt that comes out of the brine? What is the price of water? Again, if the price of water is high enough, then it will subsidize the cost of brine mining. But again, you cannot beat the thermodynamics. Higher salinities will require higher energy. That is, you'll never be able to overcome that barrier. So you want to go to higher concentrations, even with membranes, brine concentrators, the energy consumption for brine concentration is higher than seawater desalination, sometimes substantially higher. So I'm not sure that you can generalize about you can make it a general that we need to valorize brines, but it has to be a case by case situation.
Paulo?
Yes, thank you. Can you hear me?
Yes.
Yeah, I basically agree with Basil. We work quite a lot on improve the last step on further reverse osmosis plus crystallization to make it economical. But even in that case, what we see is that even because you have to go, if you want to take out and separate the crystals to be able to go in the market at a certain level of price, you need to have a certain high level of quality. First, separation of different brines. Then when you have separated the brines, you have to purify this brine, crystallize and purified with purges. And you have also to respect a certain level of size of the crystals. So when you go in that direction, you will come with multiple crystallizers, and the equation at the end of mix, you get a mix of salt. I don't see yet something that is really economical. For me now, why I was focusing before on toxicity is that uh, uh, these decisions are going for a more efficient, the tendency is going for more efficient reverse osmosis, closing the loop, is driven mainly by regulation, penalties, and specific local needs sometimes. But nowadays, I don't see for 90% of the case really a value on recovery salts from the sea, for example, because as I said, it requires in any case several steps of evaporation, crystallization, and will cost a hell. So I agree with Basil. In that case, you have to use as much as you can solar energy, wind energy, what you have locally, and also there should be a need on salts of a certain quality. If for example you are in an area in which you have a lot of chloroalkali plants, may be interesting to have a local production, make some million of investment on having no transportation from high quality salts. That's it.
Yeah, if you don't mind me adding to that, I think, just to further reinforce these comments, that what we're lacking is the need. Yeah, I mean, at this point in time, markets are fulfilled by the current sources that we have. So brine mining either needs to be cheaper than that, or we need to create another need, right? And the other way of creating the need is maybe through legislation, and again, European Union looked at, phosphorus as being a critical raw material and brought in directives to say that phosphorus needs to be recovered from wastewater treatment, right? So now Germany's installing, incineration, mono incineration to recover phosphorus from wastewater ashes, right? So the other need, a way of driving down cost and getting companies to invest more into technology developments, is by, if a legislation comes in and says, listen, the way that we are going to secure our future for magnesium resources from a European perspective is by saying that all desalination plants in Europe need to need to remove magnesium from the brine before it's discharged. Yeah, those sorts of needs will help drive down this cost curve, and hopefully then make this a more viable future for us.
Eric?
Nick, I have a question. Let's say this happens. Do you have an estimate how much that may impact the cost of water? If magnesium is being removed and concentrated out of seawater brines in Europe, what would that do to water prices, desalinated water prices?
To be honest, I don't see it changing the cost of desalinated water. That's my personal view. Yeah, because the cost to extract the magnesium has a cost, right? And that's expensive. So that doesn't offset then the cost of the desalination at this point in time. For me, I just see them as two separate entities. It's not that one will be able to subsidize the other.
Well, not to subsidize. I was thinking the other way. If it would have been profitable for the magnesium cost itself, it would happen anyway. Let's say it's legislated. That means that they will have to do it even if it is not beneficent for itself. In other words, it will be an extra cost on top of the desalination itself. So I would think it will increase somehow the cost of water to make the overall desalination, make sense economically. Let's say it's a new plant, two new plants, one with and one without magnesium side by side. What would that do to the water cost?
Yeah, that's a very good point, Ravi, because I've only ever heard people talking, from a brine mining perspective of going, hang on a minute, suddenly we get access to all these minerals and now, then we don't have to worry about paying for desalination anymore. And I've never seen that. I've never understood that. But you're looking at it from the other.
Again, I hope, but I can only guess that those cases happen where Basil said, in those specific places where the minerals for itself is brine mining is profitable. And then the water pays for itself and the minerals pays for themselves and everybody's happy. But in most cases, obviously, it's not happening. Otherwise, it would have happened, right? Market will not miss on that opportunity. So that something would have to subsidize or to be more expensive to cover for that extra cost. And I'm just wondering, what would that do to water price? Because at the end, despite of what I said before, water is still the main purpose of desalination, and it has to be, accessible, cost-effective, whatever you want to call it. Now it's down to about, 50 cents a cubic meter at the Gulf or in Israel. So what would that be, 55 cents or $1.50? I mean, just to...
Yeah. No, a very good question, Rabbit. And to be honest, I don't have any visibility on that. The only thing I see, though, is the reason that we have desalination at a cost of 50 cents per cubic meter is the fact that the need has brought us down to sort of optimize our costs on desalination. Yeah. Like, we've seen the cost of desalination come right down since 20 years ago, and that's because a need was in their market because we needed desalinated water. So companies invested in technologies to, improve the efficiency of operations. Yeah. So from today's perspective, it would be expensive, but that cost curve will come down if we can create the need in the market.
but I have to add, but also because discharge is free.
Sure.
That's one of the reasons water can become that inexpensive. Now, free discharge will remain, but if there is something that has to be extracted, there might be or there will be some cost added, I guess.
Sure.
Basil?
I have two points here to raise. I'd like first to go to the question raised by Christos. What does it take to make brine mining economical? And definitely technology. Definitely technology, better technologies will make it more economical. And by technologies, I mean ion selective extraction technologies that will selectively extract a valuable ion out of the brine and and leave the others in there. For example, things that will go for the potassium or go for the lithium or for the magnesium or for rubidium. That I think that kind of technological development will make brine mining industry. Now, the lithium industry can valorize brines that contain 50 ppm lithium, which was not possible a few years ago because they developed direct lithium extraction technologies, which are economical when the concentration of lithium is around 50 ppm. We need similar technologies that will target specific ions and extract them economically and leave the ones that are not important in place. That's one point. The other point I'd like to talk about is it can be brine mining. It can be from seawater. It can be economical. For example, currently we are working on a situation, a plant that needs salt, and the current salt cost is around $50 per ton. Okay, and they have to use chemicals for purification of the salt. Now, this can be a situation in which the economics will work because that plant requires also water, and the water that it has to pay a high price for the water that they use. So you can give them water, and you can give them, and you'll definitely be able to give them water at a lower price than the current price, and at a lower, higher purity salt at a lower price. So it is definitely a case by case, and it's a matter of finding the right project, the right. Really, sometimes even makes more environmental sense to do brine mining for those projects because you eliminate transportation of salts, you eliminate, for example, transportation of water, which can sometimes can cost as high or even more than the cost of desalination itself. So I think there is hope, especially with membrane brine concentrators. It's just a matter of finding the right project and finding the right economics. So it's not a hopeless case. I think membrane brine conservation made a lot of progress and made this industry more feasible, more viable. But it's a matter of finding the right project.
I think you're right, and definitely the Indonesia project of HYREX showcases it that one, it can be done and it should be done when the economics are right. Personally, as far as I'm concerned, brine valorization can happen only when you apply economy of scale due to the relative expenses. And for this, I'm trying to push the idea of central separation hubs. Not it cannot happen in every single project. Even big projects cannot do full brine valorization and recovery of critical minerals that Nick mentioned. But it can take place when you apply enough feed that you can get the product that can excuse like a decent ROI for the project. And this is the case. And of course, when I'm talking about brine treatment and zero liquid discharge, of course, it's not going to happen unless the legislators put a knife literally on the throats of the end clients of the industry, either by raising the water costs or by denying them access to the network from a limit up. That's my humble positions on the topic. But you're all people that have heard time and time again claims from technology suppliers and startups during the last couple of decades. And you have seen the relative results. But where do you think that technologically, as an industry, we should focus on right now when it comes to the brine treatment, brine valorization chain? David?
I think the answer is in that partial. The dream to completely recover and disconnect major I'm talking seawater, large seawater desalination plant from ocean discharge is too remote at the moment, and in the foreseeable future, as far as I can see that. However, it doesn't mean that there's no brine valorization and recovery and mining and whatever you want to call it potential in there, and that could come definitely, as Basil said, on a case by case situation, and as Nick mentioned, as a potential on a specific legislation, not a DLV legislation or whatever you suggested, Christos. This cannot happen. The price of water will just not make desalination feasible again at all, and legislators or regulators will not risk that. They will rather go the California way of just looking at other water sources rather than desalination, which raise other concerns and other issues like reuse, potable reuse, and other things. But as long as desalination is there, and in some countries it will be, uh, it will not be an either or. Either like now, just discharge and forget about it, or completely disconnect from the ocean and ZLD everything. It will be somewhere in the middle. And also the technologies will be very specific. So if hydrogen makes sense, the focus can and should be on, say, hydrogen production. If magnesium makes sense in Europe, it will probably go the magnesium way, and forget about sodium chloride or for that case. And a case by case is critical. I can even give one unusual example when it's not even really brine, but at least there's one desalination plant in Israel where it's co-located with a big coal-fired power plant, and they use the second pass reject. They call it boron water, and they use it as makeup for the FGD of the power plant because it's fresh water for them. It's very clean water, but of course it's not usable because of the boron for desal, but it's perfect water for the power plant. So there is a valorization. It's brine in a way. Of course, it's much more diluted than the real brine, and it's a small quantity compared to the big discharge, but still there's a value there, and just by the co-location, they get value out of that effluent in a way.
Thank you. Basil, I see that that the hand is still up. Do you want to say something or okay?
Yes, I'd like to say something. Yes, there is one more use case in which brine valorization can make value, make sense, and that is when there is a limit on the seawater intake. So there's a limit on how much seawater you can take. Then you want to extract the maximum amount of water out of that intake that you have. So in that case, yes, you can probably use membrane brine concentrators to increase the recovery of your desalination. And in that case, the economics also might work because your brine is already pre-treated. So it's supposed to be very clean and will not require further cleaning. You don't incur further costs for intake. Sometimes, in some cases, that's around up to 20% or more of the cost of the desalination. So you already avoid the intake. You spend a little more on the energy, but the economics might work in some cases. Again, so I think that is a case. Probably we'll see more of if there is any, for example, some seas really have truly serious limitations on how much intake is allowed because that country has very little access to the sea, so you cannot have like 5 or 6 intakes. I think that's a very good case, and we're seeing some some requests about that kind of business. Okay, so I think that's that I wanted to mention that, and in terms of technology, as I mentioned, I think selective ion precipitation removal remains a very high priority for technology development for this industry, especially if there is no value for the salt that you extract. Yes.
Thank you. Eric?
Yeah, I think the selective ion separation is like the holy grail of this. That would be amazing. I think on the near term, I think we're starting to see more innovation in kind of the small steps and improving the nanofiltration membranes that are needed to separate the monovalent and divalent. I mean, it may seem like a minor step, but when you look at partial valorization, the purity or the effectiveness of that separation plays a big role in the final economics of what you're trying to valorize. And kind of in the next step, we're starting to see improvements in OARO type membranes. They're getting more and more efficient. They're going up to higher pressure, so we're starting to see potential for fewer stages, which lowers capex. So those are all big, they seem like small steps, but I think they're going to have a significant impact in the future. And then the last thing is, I think the final step, either different ways of doing electrochemical precipitation or electrolysis for things like magnesium, or even new types of crystallizers. I'd be curious to hear what Paulo thinks on some of the newer type research and different types of crystallization technologies, things like solvent extraction or enhanced type crystallization, membrane crystallization. I'd be curious to hear what he thinks and how that can impact the cost of brine valorization.
Thank you for the question. I think that always what we suggest also to our current customers is that they need to go as far as they can on the concentration of the brine. Okay, because we for sure have improved. Last step of the crystallization part, but as also Basil mentioned, when you go up in concentration, even with further reverse osmosis or improved crystallization, you go up on energy consumption. So this is always an equilibrium on capex opex to be seen. What is really applicable case by case, and in some cases, even even a small rule on legislation on that obliges to recover water could be of interest. Okay, could be of interest. What we saw is that the limit for us is always the solidification. Let's say when you get after, depending on the brines, okay, depending on the percentage of dissolved salts, when you start getting over already 15%, not even 250, you already start having crystals appearing. So that you are using whatever technology, you have start crystal appearing. So you need to know how to deal with these crystals and how to design the equipment to deal with these crystals. And what we saw is that most of the time, many designs we found are not taking care of that. So after a bit of time, you get blockage, you have to clean it every 15 days, it decreases enormously the amount of operation or chemical you have to add, stuff like that. We believe that really to close the last step, crystallization, and improved crystallization, focus on recovery water, because one thing is focusing on recovering water and have a mix of crystals, and one thing is have one pure crystal. The design is quite different. So we that's why we took that way. We took the way of trying to reduce the cost, the size, the amount of energy consumed, with the idea of you get a mix of salts at the end, and with this mix of salts, if there is something really important in there, you make a little second step of liquid extraction, for example. Okay, but for us, it's very important this last step. That is, when we started making calculation, it cost like 70 to 80% of the global ZLD plant. So if there is something to focus on, is that one. Then for sure, all ion separations helps on purity. All purification helps, and there are technologies in the market that, let's say, allow you to do that in a less cheaper way. But is let's say, big crystallization companies has always thought about high purity crystals. Uh, uh, yes, you know, the high reliability is not the water market. You know, they have another mentality. They are coming from heavy chemicals, high purity. So you need to rethink. And we think the future is, let's rethink the full process to make it really economical. So more
Actually,
industrial people will use it.
Puzzle?
yeah, I have to say this because this is a problem that has been bugging me for a long time. In the West, we are able to remove the balance very effectively. We know how to remove sulfates, calcium, magnesium. We have extremely very good membranes, nanofiltration membranes that can do that. And the only thing that we need to crystallize for is the removal of potassium, because you cannot use brine that contains potassium for the chloralkali or for the soda ash industries. If there is a way to clean the brine from potassium, then that's this. We don't need to crystallize. That's the thing. You know, you can use. You just need to achieve 200, 250,000 ppm using membrane concentrators at a low cost, low energy consumption, and then you can feed it directly to the chloralkali plant or to the soda ash plant. The only problem we have with this concept is the presence of potassium. And the only reason we have to crystallize is just to mainly get rid of the potassium. So it's basically a purification process. If somebody comes up with a solution that removes the potassium, I'll give them business immediately. So, Paulo, you seem interested.
Yes, yes, I definitely am. We can talk aside.
Okay, you have my email.
Great. So,
Great.
one of the final questions from my side is that we were hoping we're all hoping as part of this brine related space that mega projects would accelerate, yeah, the development of brine technologies and brine projects worldwide. Um, what do we do if these mega projects fail? What other alternatives do we have as professionals to push for the commercial installation of brine treatment, brine valorization projects?
I'm sorry, I'm not sure I agree with with the statement that mega project is the way that this thing will advance. I think that Basil said it correctly. It's a very specific thing and a case by case, and I would focus first on non-seawater applications like inland and brackish, where there are some other external reasons, like Basil said correctly. Sometimes the extraction of groundwater, the limitation on that, or the discharge of brine into ponds or whatever, like in the oil and gas business, and also sometimes groundwater or inland water are actually rich in a specific mineral, specific thing that makes it slightly more cost effective or easier to extract or to refine. And so, and the more of those that will happen, the lower hanging fruits, the smaller, medium size, inland, industrial, those will create the basis, or we need to stop asking the first questions on this meeting. What is brine? And does it make any sense to valorize it? The answer would need to be yes, depends where. And then just start with the with the last part of the discussion. And this would happen with more and more successful and profitable examples rather than major mega things. I just heard that Neom is taking kind of a back burner now. And so I think we need some great case studies. And then we need few more great and bigger case studies. And then just like desalination happened to begin with.
Look, I think one of my concerns with these mega projects as well is that sometimes they're not focusing on need, right? We've said we need that metal or that mineral out. We're trying to create a concept where we're trying to extract all these different metals and minerals simultaneously, yeah. And if you build your business case around that, the moment that all of a sudden one of those falls down, suddenly there's a surplus in the market, and we don't need to extract that, or we can't valorize that. The impact that has on your whole value chain, on all the other metals and minerals that are trying to be extracted at the same time, right? Because if you've developed a process that you need to get this much out to get this out to get this out to get this out, right, then you may end up in a scenario where you're stockpiling certain metals and minerals because you're not able to bring them to the market, you know. And I am a bit concerned about the fragility on those business cases around those things. And if the focus was more on a specific product, you know, in a specific market, in a specific brine, that would have a lot more sense for me.
Thank you. Well, as far as I'm concerned, we definitely, what David says makes absolute sense. Yeah, we need reference cases and success stories in order to build the commercial growth of Brine. What I'm still worried is that even in cases that it is actually needed, they are not gonna. And I have a case, for example, of a chemical hub in an arid area here in Europe, that they need water, they need vacuum salt, and they still won't push the button to go ahead, and they will do it only if someone comes over and does a build own operate project. The need is clear, yeah, but they're still not gonna do it, and because there is no reference, and they won't take the risk. They prefer someone else to come and do it, and this is why I think that in this time in the brine space, we need venture capital to come in and do BOO projects. I don't know if you agree with me or not.
I'd like to say something about that. I think I agree with you. I think that's a main hurdle for adaptation of the technology, because it's a new thing and people don't want to take the risk, and I don't blame them for that. And the build own operate model is the perfect model. And I mean, in our company, this is what we offer to customers, because we have been through this like 10 times, and everybody we come back with the same answer: this is a new technology, we don't want to take a risk. So we figured out that the only way to do this is to do it on a build own operate basis, because where we assume the technology risk, because we know our technology, we trust it, we have been running it for a long time. So to us, it's a no-brainer. But selling is hard, especially technology selling is hard, and especially if you deal with commercial companies, big companies that work with proven cases. They have a specific mind. They are not in the business of taking risk. They have no interest in taking risk. They are happy to pay more money to have a guaranteed supply of a certain material. And the only way to make this happen is to do it on a build own operate model. And I don't blame them. I don't blame them at all. If you have a technology, you are confident of your technology, then find somebody to finance it, convince him, and then go and build it on your own. And by the way, in this way you make more money, It will be a continuous revenue instead of just selling one piece of equipment one time and then wait for the next sale. This can generate, I think it's a beautiful business model to do this in a build, own, operate.
Yeah, I think I would agree with both Ravid and Basul, and that we're, from our point of view, we're seeing a lot of different brine valorization projects in the world, mostly in China right now, and they're hard. A lot of these are mixed wastes. They have contaminants that are very difficult to treat, but people are taking risks. They're they're putting in the time and the effort to figure out the first time, and there has to be some sort of funding mechanism to allow these companies to push through and figure out solutions and come up with an economic model. And especially in like battery manufacturing, we have all these waste sulfates, either ammonium sulfate or sodium sulfate. In China, almost every new battery manufacturing plant is valorizing those brines to some degree. And it was a lot of work in the beginning, but it's now a profitable brine valorization. We're seeing the same thing in lithium batteries, able to recover different sulfates, like nickel sulfate, cobalt sulfate, in addition to lithium. So it's doable, but it really does take some vision. It takes taking on quite a bit of risk often, and often that either needs to come from government sources or from venture capital or someone who's willing to back that risk.
Thank you, Eric. Paulo?
Yeah, yes. If I may give the point of view of the experience for a startup, because we launched our company last year, is that definitely is we saw two things. The first, as Basil and you said, the big companies don't want to take any risk of any kind. So you have to mainly focus on a small company with a big problem. Okay, you talk to the owner, and that even in that case, you need support from local government, small angel investor foundings. Just you demonstrate that your pilot is working. So we are, even if you are very much convinced of your technologies and you have in your team worldwide experts, the point is that there is a lot of people selling, let's say, dreams to customers. I never see something like that, only in water maybe. There is a lot of companies promising crazy things. So when you come in, even with a kind of small test piloting, basically they don't believe you. You need to show. I think it's because of the history of bad investment, bad testing in the past. So, and it is going by steps. Okay, it's going by step, by piloting, testing, showing that it's working. Then you go bigger. Then in some year, you gain trust on your team, your technology, and you grow like that, and the technology will grow. I think this will apply to all the water system in the next coming years. But there is a lot of things moving, a lot of things.
So my next question is, how can we attract more venture capital in this space? And as Paolo mentioned, there are a lot of snake oil merchants, per se. Shouldn't we self-regulate as a community to kick them out?
Okay, I'd like to say something about this too. Okay, so let's say, based on my experience, the only what seems to be free venture capital nowadays is the environmental venture capital. Those people are willing to take risks. They practically do that for charity or for God's sake or for whatever. Many of them, the big venture capitals, are doing it for the sake of good earth. So I think those should be targeted. I think whatever concept you want to sell to those companies should be an environmental concept. And to make it an environmental concept, it's not easy. I mean, we have been talking about this since the beginning of this call, that it's not always environmentally harmful to discharge the brine. In a lot of cases, it is really harmful. I think those ventures are a good target for supporting these projects. And I personally believe that it's if you have the right business case, it can be a very profitable business also. So it's not I mean, based on practical projects that we have done, you can really make money out of this space if you have the right business case. But this is just to me an answer that came to my mind when talking about what kind of venture capital should be addressed. Not the conventional venture capital. They're not interested. It's not their. I mean, there's nothing in it for them. But the environmental people are.
Okay. Gentlemen, before we close this first session of the Brine Trust, which I hope we will have many more to follow, is there anything any of you would like to bring on the table? Any question or comments? Okay. So, with that, I would like to thank you all for taking time out of your very busy agendas to be online today and share your thoughts with the water community. I think it's definitely a unique experience for me, being able to talk to you without being physically present in a conference or in another event. And I hope we can keep going with that, with many conversations to follow. Thank you very much.
Thank you very much, Christos. Really, it's a great opportunity to meet all of you. It's really, I mean, I had a lot of things, that has been, boiling inside and really wanted the right audience to share those concerns and issues with. So thank you very much for the opportunity and for inviting me to this forum. Thank you.
Thank you. It was very enjoyable.
Thank you all. Thank you so much.
Thank you.
So,
Yes.
with
Thank
that,
you.
Bye-bye.
everybody take care.
Ciao.
Stay safe.
Bye.